Hi. Now that we're moving on to the second chapter of the Sapolsky book about stress, I want to remind you about a couple of things. First, some of this material may be very familiar to you. Other parts of this material may be very different, and perhaps you've never heard of it before. That's okay. By the end of this lecture, we're all going to be on the same foundation as we move forth. And also, there are some basic concepts and basic facts in this particular lecture that I just want to make sure, even if you're really comfortable with it, that everybody is comfortable with it. So I want to begin by sharing the screen with you and with our slideshow here. And I really want you to watch this first YouTube video before we go on at all. If you have not watched it before bringing this up right now, I'd like you to pause the actual recording of this Zoom session. Take a few minutes. It's 5 minutes or so. And it's definitely worth watching, because not only do you get to meet the author of Why Zebras Don't Get Ulcers, you get introduced to some very important principles, basic but important principles that we'll be utilizing throughout this course. So for right now, stop this Zoom recording and watch the video. I'm going to give you a minute to do that and then start me up again. Okay. Okay, assuming that you've already watched this YouTube video, and there's no way I can ever come close to Robert Sapolsky, but I will do my best to make sure that the material that I'm presenting is understandable and hopefully meaningful and hopefully not too boring. Anyway. Basic concept. We need to know this. You will have to repeat this to me at some point, whether it's an oral exam or whether it is in a written exam. These are fundamental points. When we talk about the nervous system, we're talking about two separate divisions, and this is the vertebrate system that we're talking about. Right now, we are not discussing invertebrates at all. So that is maybe something that people overlook, but is actually an important concept. So what are those two divisions? Number one, the central nervous system, which we will lovingly refer to as the CNS. And it's easy to know which parts of our system are included in the CNS, because anything that's located within the skull or down in the spine are part of the CNS. So we're talking specifically about the brain and the spinal cord. Now, the other division of the vertebrate nervous system is the peripheral nervous system, the PNS. Now, later on, we're going to see another subdivision that also uses the acronym PNS, and I'll point that out when we get there. So, first off, we have the somatic nervous system, the SNS. And that is the part that actually interacts with the external environment. Okay, so it is the part, not your brain, not your spinal cord, but that portion of your nervous system that is taking information in from the environment via afferent nerves, which carry sensory signals to that brain and spinal cord from the skin, from muscles, and other things associated with your understanding of what's going on around you. So afferent. Lots of times, even in writing, people kind of miss the difference between affect and effect. Right here, that's important. Affect. That's where afferent nerves come from. So afferent nerves are those that are bringing information into you that will affect you some way. And efferent, the effect of that information, will then carry motor signals to those skeletal muscles from the CNS. Sorry, that's supposed to be from. Anyway, so we've got this system that does, yes, communicate with the central nervous system, but it's kind of like that hook, that connection between our central nervous system and what's going on around us in the external environment. So make sure you're okay with that stuff. And then there's the autonomic nervous system, or the ANS. Now, think about autonomic sounding a lot like automatic. This is the part or the portion of your PNS that regulates your internal environment. Things that you don't want to have to spend time thinking about. So you should absolutely love your ANS. Afferent nerves from this system carry sensory signals to the CNS, but instead of carrying signals that we're receiving from the environment, we are seeing signals from the internal organs, whether it's from your stomach, your large intestine, your different organs that are within your abdomen or other portions of your body. So the idea here is that you still have signals going to the CNS from something. But in this case, it is not from the external environment, it's from the internal environment. And then efferent nerves, just like we saw in the SNS, carry motor signals to the internal organs from the CNS. So we have that same kind of loop, if you will. Okay, in the somatic nervous system, we have information coming in, let's say from our fingers right now, tactile information, or from our ears, auditory information. With afferent nerves, those sensory signals are traveling to the brain and or spinal cord. And then that CNS decides what to do with that and carries motor signals in response. And with the autonomic nervous system, we're just talking about that information coming from inside of you instead of outside of you. And next, we've got the autonomic nervous system breaking down into two branches. And as I'm going to mention soon, you will see that this whole nervous system is basically a system of twos. The first branch is the sympathetic nervous system. The second is the parasympathetic nervous system. Before we go on, I want to have you follow this little diagram through and you will begin to see. I could go more into detail later on, we might a little bit, but for now, this pretty much explains the whole setup. So we have the nervous system, as you can see at the top, which breaks into two systems, central nervous system, and now over to the peripheral nervous system, or the PNS. Staying on that side, we have the PNS breaking into two different sections. The motor nerves and the sensory nerves. For now, I mean, that's just a very generalization, but which then go to your somatic nervous system and your autonomic nervous system. At this point, we are now at the bottom looking at the sympathetic nervous system and the parasympathetic nervous system. Here's another illustration that you can take a look at your convenience, just to kind of get some reference points. So let's go and put these different sections of the nervous system into context with what our topic happens to be, and that is stress. Actually, that's pretty much why we have these two separate systems, is to help us deal with stress of various forms. And we're going to learn to kind of define stress in a slightly different way as we go through. So first, let's take a look at that SNS, sympathetic nervous system. All organs controlled by the SNS act in sympathy or all together. And originally, that was the way it was actually named, was act in sympathy or together. Sapolsky and I are on the same page, and I feel really happy about that because he's so smart. That if you think about it, that the brain is sympathizing with the viscera, meaning your internal organs and responsivity to things, or vice versa. That makes it sense. It's like, oh no, you have something pretty scary going on. We have to do something about it. I have so much sympathy for you. I want you to survive. For example, you are running from a bear. Not necessarily a great place to be, and at some point I will definitely digress into an area about bears and how it depends on which kind of bear you are encountering. That should dictate what your response should be. As a lover of the wilderness and someone who used to spend a lot of time with primitive camping in areas where there were moose, I love the moose, and occasionally bear, I started paying attention to these things. We'll get there later on. Anyway, let's say you see a bear and you have not had this lecture yet. So you're like, all I know to do is to run. What do you need to happen to run? You need your heart rate to increase. You need your respiration to increase. All this will help get your blood pressure up to circulate your blood. And it's going to be differentially circulated. Again, we will be looking at this a little more in detail as we go. But for now, our system is going to direct blood away from the intestines and to the heart, the brain, and working muscles. The muscles you need to get you away from the bear. I, by avocation, am a musician, so I need my fingers and other parts to work to either press keys on a keyboard or strings on a guitar or whatever, okay? Right now, those little muscles are not important because if I don't escape from this bear, I'm never going to be playing my keyboards again. So let's get my blood to my larger muscles, particularly in my legs, to help me run. And this sympathetic nervous system mediates what we call the 4 F's of behavior. Talk about that later. Just want you to have that in here right now. Some of you already know because you've either had me in another class or maybe you heard this somewhere else, but we will talk a little more specifically to these 4 F's in a bit. And the sympathetic nervous system actually releases chemical messengers that are very important for coping with an emergency response to help you get safe. One is epinephrine, which is the Greek word that means the same thing as adrenaline, which is Latin. Some of you have heard it more from epinephrine because, for example, if you have asthma, Another little thing that I've learned to deal with, and what you don't want bothering you when you're running from a bear or angry mama moose. Epinephrine, they may give you an injection of epinephrine if you're having a really bad attack to help you, or if you're having an allergic reaction to something, you get epinephrine to help stimulate the sympathetic nervous system. Others of you may be more familiar with the term adrenaline. It's like, oh, I've got an adrenaline rush. Athletes tend to think more about this particular chemical messenger in terms of being adrenaline, even though it's the same thing as epinephrine. This particular chemical messenger, biochemical, is released from the adrenal glands, but not just any part of the adrenal gland, from the adrenal medulla. Okay, so if you take a look at an adrenal gland, and I've got some illustrations coming up. I hesitate to flip back and forth between 5 million different illustrations, because sometimes I think that is more disruptive than anything else. So I'll talk to you guys about that as we move through the semester. But the adrenal gland is almost like a triangular shape that sits on top of your kidneys. And there's a core inside, and then there is kind of an outer shell type of tissue. It's that inner part that is your medulla of your adrenal gland. There is another chemical messenger that we will talk about that comes from that outer part of it, which is called the cortex, exactly like your brain. The other particular biochemical here is norepinephrine, or noradrenaline, same thing, is released from all the other sympathetic nerve endings that run throughout the body. And it tends to do very much the same type of things as epinephrine. These particular nerve endings project from the thoracic and lumbar regions of your spine. Thoracic, that's your chest portion. Lumbar, that's that curved part towards the bottom of your back. You've heard of lumbar cushion, things like that. Lots of times people have trouble with that part of their back. The second section of the sympathetic nervous system, excuse me, back up. Second section of the autonomic nervous system. Please excuse me. I'm not going to go back and erase that, because that's what would have happened in class. So this is going to have like things like might happen in class, except I'm not probably going to be like falling down as much or whatever, or running into things or spilling things, whatever. Anyway, the second part of your autonomic nervous system is your parasympathetic nervous system. Now, if your sympathetic nervous system is the part to go, oh my gosh, there's an emergency, we need to get out of here, scream, run, ramp everything up. The parasympathetic nervous system is that section that kicks in when you're like, I'm out of danger. Man, I actually ran faster than that bear. I am so glad I booked a cabin this time instead of being in a tent, because I can run into my cabin, I can shut the door, I can put that bar down, bolt it, and phew, I am safe, I can relax. So I am going to get back to the status of relaxation. Everything is okay. Now I can start digesting the food that I didn't finish digesting. Now I can start working on growing and cell renewal. So Now I'm safe from the bear. I don't have to run anymore. I can let my blood pressure and heart rate go down because I don't need to be pumping that blood that's carrying oxygen and glucose to all those other areas of my body. Now, there is a biochemical, a chemical messenger that is released when the parasympathetic nervous system, the PNS, is activated. And that chemical is called acetylcholine. A little interesting kind of accent there for a minute, sorry. Anyway, acetylcholine is the chemical that is associated with activation of the parasympathetic nervous system. Now, the nerve endings that release acetylcholine project from the brain itself and from the sacral region, which is that very low part of your spine. Okay. On this slide, I have given you a little bit of an illustration of the glands in our bodies that are associated with these systems that we've just been talking about. Up at the top, you can see your pituitary gland. Again, we're going to be talking about these over and over and over and getting a little more precise and more specific as we move through this semester, as we go from chapter to chapter during the course. Parathyroid gland, which is probably one we'll talk the least about. Thyroid gland, moving down the thymus gland, you can see where that area is, just kind of above where your heart is in your chest. The adrenal gland that I talked about, sitting on top of the kidney, and the pancreas. You can see the pancreas is more on your left-hand side. Your liver would be more on the right-hand side. And then we're going to include the ovaries that are in females and the testes, which are in males, as some of the glands that are directly influenced by initially the pituitary gland, but in part by activation of different aspects of your nervous system. This is mostly for your reference. If you don't want to bother looking at any of the other resources I have given you. So I'm not really going to talk much about this right now. If you're interested, take a look, try to orient yourself a little bit. One of the biggest things is this, the pituitary gland that you can see dangling there towards the front bottom part of your brain. Okay. So now that we've kind of looked at a couple of illustrations and maybe given you a bit of a breather in terms of the actual text or meat of our lecture, I want to go on to a certain point. Although these two divisions, the sympathetic and parasympathetic nervous systems, are dominant at different times, there is an overlap at certain points. Think about the brake and gas pedals of your car. If you want to get away from somebody, somebody's following you, you need to lose them, push on that gas pedal. That's your sympathetic nervous system. Or, oh my gosh, everything is done. I'm putting my brake in. I've just got to sit here and breathe again. That's your brake pedal. Now, one of the times that these two systems overlap, so it's like you holding one foot, which this is not the way you should be driving, but let's just say for now, one foot on your brake, all the way down, press that brake down. Then your other foot on the gas pedal. You know that at a certain point that becomes not healthy for your engine. I had two brothers who were involved in drag racing when we were teens, and they were younger adults. And so I kind of was exposed to that. During sexual excitement is one of the key times when you're going to see both the gas pedals pressed down and the brake still on. The parasympathetic nervous system, remember, would be like your brake. And that would be what would increase genital blood flow and lubrication. That is important for sexual activity. And the sympathetic nervous system, your gas pedal, is increasing heart rate, respiration, blood pressure, but ultimately triggers orgasm/ejaculation. When we do the chapter on reproductive behavior or stress and reproduction, and I spend a couple of lectures on that because there's a certain degree of detail that I think is important, and I'd like to add a little bit more to that. We will talk more about that specifically. Okay. You need to take a breather. Turn me off for a minute. Because I know this is different from class, and I want you to be able to hang in there. So get your drink of water or whatever you need right now, and we're going on now to Roman numeral 2. The idea that we looked at all those other glands, your brain is the real master gland. Historically speaking, it was originally thought that all those peripheral glands, that is the pancreas we saw, the adrenal glands we saw, the ovaries, the testes, the thyroid gland, each one independently knew what to do. And because they knew what to do, they independently secreted hormones. I'm sure you all know the definition of hormone, but I've got it here just so everybody is on the exact same page. By definition, hormones are chemical messengers that are released by endocrine glands, which are ductless, no ducts to the external part of your body, directly into the circulatory system. There they are carried in the circulatory system until each one reaches its target. Now, I always, I guess to some degree, well, actually to quite a great degree, enjoy this little story. There was something called rejuvenation therapy that was developed by scientists who thought that the male sex drive declined with age because there was a decrease of what they called male factors in the testes. Now, clearly this was not within the last 2 or 3 decades. They did then extend the idea to aging in general. In other words, the male not only had a decline in sex drive, but also aged not so gracefully because of this decrease of male factor. And of course, you know, I'm going to say something about this. They didn't seem to care too much about females because this was totally directed towards the males of the population. So they started drawing out with syringes extracts, what they would call material from the testicles of dogs, roosters, monkeys, goats, etc. Make an extract that they would then inject into their patients, their males. And thinking that what was lacking in those males would be found in the extract that they withdrew from these different animals, from the testes, and that then that would give those human males what they needed to experience increased sex drive and to be more youthful all the way around. The goat of choice thing is really interesting to me. Those of you who've never had me for a class yet don't know that one of the things that I've done in my past, because of my passion in part for animals, was raise dairy goats. And I ended up with way more goats than I needed because they're so cute and I love them and they're nice. And one of the problems was, however, the buck goats, which were the male kids, were so adorable. But if you didn't neuter them, they became unruly. I'm just going to use that term right now, unruly. And so if you wanted them for a pet, you needed to neuter them. If you wanted to have a buck on premises to breed any of your does, you needed to be prepared. And this is just a little of a side story. If you're not interested, you can just fast forward. But one of my experiences, I had 4 does. Those are the female goats, adult goats, who I wanted to have give birth to some kids and to be able to milk. And so I kept one buck over to breed one of those does. His name was Sherman because he was like a tank, and I mean an army tank. So he had his own huge pen on one side of my barn, huge. I mean, and the stall was so high, it was well over my head. And when I had a doe who I did not want bred come into heat, I'm like, oh boy, Sherman's, he's going to be like, oh man. So I actually chained him. He had plenty of room, trust me, and he couldn't, get over. And it was a heavy duty chain, bolted into the side of the barn. I'm like, Sherman, you need to stay here. Okay, it's all good. I remember, like, within 2 days, going out to the barn to do their morning feeding and say hello and pet them and all that. And I'm looking, and Sherman is not in his, what I thought was inescapable pen. I'm like, Sherman. And I'm like, oh, don't you want to think about it? Turned and looked, and Julie, I had Julie, Tina, Mandy, so on and so forth. And there was Julie and Sherman both laying there chewing their cud. Oh yeah, it was nice. We had kind of a really good night. Thanks very much. I'm like, aye. He had literally pulled the chain right out of the barn, gotten out of this very, very high pen, let himself into Julie's pen, and had his way with her, if you know what I mean. Anyway, this was one of the reasons that they actually went to goats, because these buck goats were extremely virile. I mean, they were like, yeah, we're going for the gusto here. Okay, if you're bored of that story, we're moving on now. Anyway, this all led to testicular grafts. They are like, instead of just injecting, let's go in, take a part of the testes, go into the male human and stitch that little section of tissue right into the male's testes. This led to what they call the monkey gland craze. A lot of monkeys were losing some of their testicles for this. And so, all right, just imagine, guys, there you are. Here, I think I'll have, let me see, part of that monkey's testicles today. Interesting thought. We can come back to this in a moment. I just wanted to go on with this story first. Guess what? People reported miracles. Are like, oh, I feel so much more energy. Oh my gosh, you know, it's like, wow, I'm back to like my 22-year-old self. Interestingly, there was no way it could have worked. There was literally no testosterone in the extracts. And it couldn't even go into a water solution. And I know this for a fact because when I was doing my PhD, I literally was working with male rat sexual behavior. And I did a lot of castrations, I did a lot of ovarectomies, I did a lot of injections of a variety of things, including forms of testosterone. And we always had to mix that in an oil because it is a lipid-based biochemical or hormone, I should say. So basically, all of these injections were not viable. And when they looked later on, all of the transplants they did, the testicular transplants, had dried up, completely atrophied. They were not biologically active at all. So the fact that patients reported wonders is a wonderful example of a placebo effect. Now, the illustration on the previous slide, which no matter where I put it, it didn't seem right. So you've got access to it. Let's talk about the pituitary gland. In the brain, actually controls these glands. And it's located just over the nasal cavities. And that's why initially it was thought that it produced nasal mucus. And they totally associated it with that. And for a long time it was called the master gland. However, they thought that it was the master gland and it was totally independently on its own, directing the rest of the glands in the body, because when they dissected it out, these other glands did not perform correctly. However, what the early anatomists didn't realize was that when you dissected out the pituitary gland, you were actually destroying parts of the brain nearby. And those areas of the brain were essential for the communication to all the glands. There are two parts of the pituitary gland, the posterior and the anterior. And so if you're looking from the side and you're looking inside your brain up in here at the pituitary gland, the part facing forward is obviously your anterior pituitary gland, and the part towards the back of your head would be the posterior pituitary gland. We'll come back to that. The rest of the brain, guess what? The rest of your brain is important too. Communicates with the pituitary gland via the hypothalamus. Hypothalamus means the structure below the thalamus. It's where we refer to being on the floor of the brain, and you will hear hypothalamus so often in this course, over the course of the semester, that you will probably hear it in your sleep if you can't turn it off. So make sure that you start off right at the get-go, becoming completely familiar with what that hypothalamus means, where it is. And here we go again, referring back to this, the 4 F's. The hypothalamus is essential for the 4 F's. Gonna leave that a little mystery for those of you who aren't familiar with it yet, but we will get to that soon. So let's take a look at the idea of the hypothalamus and how it communicates with the pituitary gland. Now, first off, you should be thinking, oh, there's 2 sections of the pituitary gland. I wonder if the hypothalamus communicates differently with those two sections. Ta-da, you're right, it does. Axons from neurons that live right up in the hypothalamus actually extend down into the posterior pituitary. When neurons in the hypothalamus fire, the posterior pituitary is stimulated to release one or both of two different hormones into the blood. The one is oxytocin, which we will refer to as OT for short. And that is important, essential for childbirth, milk ejection, orgasm, smooth muscles, contraction, but also for social bonding, including bonding with an infant after childbirth. The other chemical is vasopressin. This is also called antidiuretic hormone, or ADH. Important, be familiar with both of these names for it. We will be talking extensively about it. It is important for raising blood pressure, and when it does that, it lowers urine production because it is hanging on to water that's in your system. In other words, it is conserving water, H2O. Okay, so both oxytocin and ADH, or vasopressin, are actually made up in the hypothalamus, then carry down that stalk that connects the pituitary gland with the hypothalamus, and eventually released into general circulation from those terminal buttons that are in the posterior pituitary. This portion of your pituitary gland, the posterior pituitary, is neural tissue. Neural. You're going to see where that differs from the anterior pituitary. Hormones from the hypothalamus reach the anterior pituitary, which then, in response, releases its own hormones. So it's different. And this happens through something called the hypothalamo, for hypothalamus, pituitary gland, portal system. It's a system of vessels, small vessels. And the hormones that are released by the hypothalamus, they're synthesized and then released from this hypothalamus, are releasing and inhibiting hormones. There's a variety of them, and rather than give you a list of every single one of these releasing and inhibiting hormones at the beginning, I'm going to introduce them as we go through the system so that it makes a little bit more sense. It'll be more relevant. At any rate, these releasing and inhibiting hormones actually signal the anterior pituitary to either raise or to lower the release of its own hormones into general circulation. So it's really important to recognize the difference between the posterior pituitary, which doesn't have its own hormones. It basically is a vehicle for releasing the hypothalamic hormones. That is different from the anterior pituitary, which does have its own hormones that are released in response to hormones that it gets from the hypothalamus. So make sure that you're familiar with that concept. Either way, in the end, we end up with a brain that is oozing hormones, in Sapolsky's words. I sometimes get frustrated because Sapolsky is so good at saying some of these things that I can't come up with a better way or a more interesting way. So sometimes I just have to give it to him. In fact, a lot of the time. So now we hear about these hormones and it's like, oh yeah, we've known about these forever, but not so quickly there, because it wasn't until the 1950s that there were two different labs. One was the Gilliman lab and the other was Dr. Shelley lab, that were working furiously to try to isolate and then identify these, what they called factors from the hypothalamus, the releasing inhibiting factors. And unfortunately, as so often happens between scientific labs, each one is intent on kind of winning the race to identify something or discover something or find some kind of relationship between a couple of factors. And these two labs were no different. They actually basically ended up almost in a war between themselves. And they're looking at this tissue that's tiny, tiny little bits of tissue, tiny, okay? And they have to get so many pituitary glands and hypothalami and stuff to actually get these particular hormones into amounts that they could even analyze. They ended up having truckloads of pig or sheep brains mashed into thimblefuls of liquid for them to try to investigate. I don't like to think about that part, so that's all I'm going to say about that. So remember, this was in the 1950s. It was not until 14 years after that, so we're talking into the 1960s to 70, that thyroid releasing hormone, which is essential for the release of thyroid hormone, was even discovered. And this is kind of like poetic justice in my mind. It ended up that Gilliman and Shelley had to share the Nobel Prize in 1976 because they both kind of independently came in on this discovery at the same time. So I guess you could say neither one of them actually won the war. Now, I want to make sure that you're good with, I'm just going to scoot back for a minute before we finish, whoops. And this is not a very good illustration of the anterior versus posterior pituitary and its connection with the hypothalamus. There are much better illustrations and other resources I've given you, but just for the purposes of wrapping this particular lecture up, this would be anterior, okay? I tend to always want to do things the other way, but this is the portal system that we were talking about. And this is where releasing hormones and inhibiting hormones that are synthesized up in the neurons, those cell bodies in the hypothalamus, are then released. Now, so we have these that are releasing hormones, and then from here on in, we have, let's go here, annotate a little bit more, buddy. Sorry. Then you're going to actually have the other hormones released from the anterior pituitary. So, whoops, don't like that either. Anyway, so there we go. Hopefully this has made some sense to you, and you have been able to get through this in at least one or two different settings. And I will be seeing you soon in one way or another, and I will be posting chapter 3 very soon. Take care.